Here's a solution for day 2, problem 1. Identify the x-intercept and the y-intercept for the graph of this linear equation. So the x-intercept is where this line that goes with this equation will cross the x-axis. Any place on the x-axis has a y value of 0. So if you substitute 0 where the letter y is, that makes the y term totally cancel away and leaves x equals -6. That is the x-intercept. Now for the y-intercept, where the line crosses the y-axis, all dots that are on the y-axis have a 0 as their x-coordinate. And so if we replace x with 0, causing the x term to cancel away out of the equation, that leaves 4y equals -6. And that little equation, 4y equals -6, can be solved to create y equals -6/4, which as a mixed number is -1.5. Right, with these two values, we can get dots and draw the line. So the x-intercept is -6 on the x-axis. Here is -6. And on the y-axis, it's -1.5. So here is -1, and then halfway to the next grid mark is -1.5. Draw the line. Now, day 2, problem 2. The value of an automobile, V of t, is a function of its age in years t. A vehicle is worth $24,000 new and depreciates $2,500 each year. Write a function equation for the situation. In our equation, we're relating the value of the vehicle to how old it is. The value of the vehicle is given the letter V. To connect it to its age, we use what's called function notation, where you put the other variable in parentheses. And you say V of t, the value at this many years. Well, the vehicle is $24,000 when new, so you write in that initial value, and then it depreciates $2,500 each year. So we can subtract that rate of change, 2,500 times t, where t is representing how many years old the vehicle is. And then in question B, we can use this equation to find the value of the vehicle at these different years. So V of 1, the value of a 1-year-old vehicle, 24,000, subtract 2,500 times 1. That is $21,500. I want you to notice over on the calculator when the linear equations was entered, and then looking at the table of values, when t is 1, the value of V is 21,500. Now we can find V of 4, the value after 4 years. That's 24,000. Subtract $2,500 per year for 4 years. And that is going to create $14,000. You see that on the calculator when t is 4, the value of V is 14,000. And finally, V of 8. $24,000. Subtract $2,500 per year for 8 years. Using my graphing calculator, I can scroll down in the table until I get to where the value of t is 8, and then next to it I see that the value of V is $4,000.